Hi everyone, welcome to this new video lecture of AutoCAD. In this lecture, we will see how to draw the projection of points in the AutoCAD. So first of all, we need to open our AutoCAD software, and in this AutoCAD software we can go for the new, then we can create a new page like this, and here we can draw our projection of points. So as usual, our method is there to create a drawing page. For that we can go for the MB setup. The command is there, and paper space enable no, and metric enter unit type, that is metric M, and scale factor 1, and paper width 420, and height is 297. By that method we can create our drawing sheet in the AutoCAD sheet. So before going to draw this projection of points, let try to understand what do we mean by projection and what do we mean by projection of points. So for that I'll show you this slide. Actually the projection is defined as a geometrically represented image. The image may be visual image or any kind of figure of an object. The object may be also, it may be a point, maybe a line, maybe a plane, maybe a solid, or any kind of machine components, buildings, which is often on a plane or a surface. And the plane also may be of different types, like horizontal plane, vertical plane, and profile plane is there. So the projection also again categorized into different types like orthographic, isometric, oblique, and perspective. We won't discuss that much in this types of projection. Later we will discuss about this projection: orthographic, isometric, oblique, and perspective. So first we will see how to draw this projection of points on a plane or a surface. Actually, point is nothing but a point represents a location in space or on a drawing which has no dimension actually. And to draw the projection of a point, we require not only a point or any kind of object. If you want to draw a projection of a object, then we require basically these three informations. We required an object, we required an observer, we required a location of object. So yeah, you can see this. I'll show this one. Yeah, this is good somehow. So you can see this is the observer. So this observer is the observing the object here. So observer nothing but the person who is visualizing the object. So this is the observer, and the object is, as I told you, the object may be anything. It may be a point, it may be a line, it may be a plane, it may be a solid, it may be a machine components, or maybe a building, anything. So the observer is visualizing or viewing the object. So the reflection or projection, you can say, that will be reflected on the opposite to this. So that is the location of the object, as I told you. So this is the location of the object. Object required, observer required, and location of the object required. So this is the observer, object, and the location of the object is nothing but this is the location of the object, which is it may be a vertical plane, it may be a profile plane, or it may be a horizontal plane. So this is horizontal plane, and this is vertical plane, and this is your profile plane. In the profile plane actually we can get the view of side view. While we are viewing the object from this side, so that means this is our front view. So the front view will be reflected here. So at this point we can see the front view, and while viewing the object from the top side will be reflected on the horizontal plane. Simultaneously this side will be our side view. The side view will be projected on the profile plane side. And total 4 angles are there, and the 4 angle of projection we have categorized into different quadrants actually. So as you can see, all this projection can be drawn in first angle projection actually. We are not going for the third angle projection. We won't draw the diagram in the second angle or fourth angle. We'll prefer the first angle projection. For that I'll create a new another one video So what is the difference of all this first angle, second angle, third angle, fourth angle? So basically we used to draw the diagram on the first angle projection only. And the front view will be denoted by dash, you can say. So while the front view is here, then any kind of object will be viewed here. So how to notate that one, how to denote that one? By a dash point. Suppose the point P is given, so to draw the front view of the P point, so we need to mention it P dash, and if it is a line, then we have to mention as P dash and Q dash. Similarly, the same point top view need to be drawn, and that need to be denoted by P point only, because point only single. So only you need to mark different notations for that, for front view P dash and top view P. And the same line, if you consider a line, and that line is PQ, so the top view will be mentioned marked as PQ. Similarly, side view will be given by the double dash, P double dash, P dash, Q dash, for point P dash, and for line it is P dash and Q dash. So we can see this is the vertical plane, and this is the horizontal plane, and this is the first angle or first quadrant, second angle second quadrant, and this is third angle third quadrant, and this is fourth angle and fourth quadrant is there. So here another two points are coming for this. For horizontal plane we need to consider above and below. This is the, suppose this is our horizontal plane, so the point located above HP, that means this is the HP, above HP, or maybe below HP. So these are the two words we need to remember. Another thing, for vertical plane, what you need to remember? We need to remember in front. This is the vertical plane, so in front of vertical plane. Another one is behind the vertical plane. So this is vertical plane, this is behind, and this is front. This is HP above and below HP. Now we will see the location of the point. So this is actually the different angles of a plane, what I have told you previously. So this is your vertical plane, and this is our horizontal plane, and this is the right profile plane, and this is our left profile plane. So if you keep any kind of object here at this angle, at this quadrant, so that will be if the point is, suppose the point is located here, suppose, then the indication, the location will be called as, like, the point is located above HP and in front of VP, in front of VP and above HP. So the quadrant will be the point is located on the first quadrant. And how to draw it? So the front view will be above HP, so above HP the front view, and top view will be below XY. Why? Because top view will be below XY. While drawing the projection, this horizontal plane will be rotated 90 degree actually. The vertical plane will be as usual, and while drawing this you can say this horizontal plane will be rotated 90 degree. So it will be rotated here like this, it will come to above, and this horizontal plane will be goes down, and this line is called your reference line, and that is your actually XY line you can consider. Similarly, while the point is above HP and behind VP, above HP and behind VP, that means it is in the second quadrant. In this point, the point is above HP and behind VP, so it is in the second quadrant. So what about the front view? So if you look the view like from this side, so let's see, the observer is here and it is viewing the object here. So this is the front view will become here in the vertical plane. So front view will be at this vertical plane, and that will be above XY, because this is the XY line, so it is above XY. And what about the top view? Top view will be here, so that means the top view will be from here you are viewing, but the projection will become under this on the horizontal plane. While doing this projection, as I told you, we need to rotate the horizontal plane. So this will be rotated, means this horizontal plane will be mixed with this, or it will be meet with the vertical plane. So both the point location will be above the HP. You can see above the HP. So third point we will see below HP and behind VP. As I told you, this is our horizontal plane. So below HP and this is HP, below HP and behind VP, that means at this point. So this point location is the third quadrant or third angle projection this is. And the front view will be, if you see the front view here, then the front view will become at this point, and top view, like as I told you, top view this one. So that means we need to think that top view will be here and that will be projected here. So it will rotate, means it will be go up and front view will be down. So that is below XY, you can say below XY, and this is as it is rotated, so it will go up, so that is above XY, that is top view. Similarly the fourth, if you come to the fourth quadrant, so below HP, as I told you, this is our HP horizontal plane. So the point located is below HP and in front of VP. So the point located here. And what about the projection? The projection will become below XY front view. Let's see, this is the front view is there, and the observer is observing the object in this fourth angle or fourth quadrant. So the front view will be reflected here, and top view, if you see from here, then the top view will be come on this plane, but it is going to rotate. It is going to rotate like this, so this plane will become down, and this is also already below XY, and after rotating this one, this also come down. So both are below XY. So next location is on HP, that means on the HP itself, on this plane itself, and in front of VP. So that location will be first, it may be a first quadrant or maybe fourth quadrant, any one quadrant it may be there, and it will be located, front view will be on the XY and below, top view will be the below XY. So similarly above HP and on VP, that means above HP on VP. So this may be on first quadrant or maybe second quadrant, both may be possible. So like this, all the 9 different types of locations are there on HP, behind VP, and the plane location, which quadrant it is, and what is the front view and top view, and below HP and on VP, and that will be third quadrant and fourth quadrant, and the front view will be XY, below XY, and top view will be on XY. And another one point, final one, on HP and VP. On HP and VP means that is nothing but on the reference line itself, on this original line itself. So the front view and top view both will be on the reference line. So the front view and top view both will be on the reference line. That location will be on the reference line. So let's try to solve some problem related to this. Some questions I have taken here. So for that we'll go for this AutoCAD, and let's draw the line here. As we know that we can draw this, enter, and see what the question is given. First one, draw the front and top view of a point A lying 70 mm above HP, 70 mm above HP and 50 mm in front of vertical plane. So this belongs to the first type, this one. So first quadrant, so front view will be above XY. So front view above XY, that means it will come on the vertical plane. So we can draw very simple. First we'll give the text here. And this is your XY, and next you can select the line. How much is there? 70 mm. 70, and below how much is there? Below is given 50 mm in front of vertical plane. In front of vertical means then it will become below the XY line. It will come below the XY line. So I can draw here 50. Okay, so our job is done. Now for this we can give dimension. Dimension is compulsory, you need to give linear dimension, and while giving the dimension we need to check it properly, and the dimension should be aligned both in the same. You can see 70 and 50 should be placed in the same location and same reference line. It should not be zigzag here and there. and so this is the first one, so A point. So for this A point, as I told you, so location also we need to give like text, single line text you can select here, and we can give here 30. This is A dash, and top view will be A. That's it. So this one you can give it, keep it here. This is already there. So this is your first point. Similarly, we'll go for the second question. Second question, what given? Draw the projection of a point lying 70 mm above the HP and 50 mm behind the VP. So lying 70 mm above HP, second quadrant or first quadrant, and behind VP means that is second quadrant. So this question belongs to second type, and it will be placed on the second quadrant, and both will be above XY line will be there. So let's draw this in the AutoCAD. So similarly, select the line. Now this gap between this first one and second one, it's up to us, because in the question nothing is given. If the question will be given, keep the distance, maintain some distance between this point location to point location, some 20 mm, 30 mm, then we need to measure from here 20 mm or 30 mm, then we can go for the another one. So otherwise we can go simple like that, and let's see, we'll select how much above 70 mm, above 70 mm, and 50 mm behind. So another one point will be there, 50 mm. We'll give some point style for this. PO, enter. Yeah. Inside location we can give by different command is there for this, or else we can give this one point style. We'll select this. Okay. Similarly, point this one. Another one point is this, and another one line is there, which is 50 mm. 50, enter. PO, enter. You can give this 50. Now again, dimension need to be selected. Dimension from here to here. We need to keep some gap actually between this diagram to diagram, and from here to here again 50. It should not be overlap this one. Now we need to give the text for this. This is the B point. So keep here. Another point, we'll keep it here. I have copied this one actually. So this one we can give, what is the location given? It is 70 mm above. That means the front view will be there. So I can go for it B point and B dash, and this is here B point, not dash. Third question given what? Now draw the projection of a point C lying 70 mm below HP. That means it will be third or fourth quadrant, and 50 mm behind VP. Behind means then it will come second or third. So obviously this question belongs to third quadrant, below HP and behind VP. So third quadrant, the front view will be different and top view will be different. So it will be reverse of the first one. So it will go like what we have drawn in the first one, that will be the reverse actually. This will be come down and that will be come up. Anyway, we will draw this. So this is the, let's take any location of this point, any point location of this, and how much will be there? 50, enter, and another time this will be there 70. So here again we can give the point, any one point style, and this one I can give one more point style, and here also we need to give the text. Let's copy this, paste, and let paste here. So here this will be different, like C dash, and this will be C. Next point is draw the projection of D lying 70 mm below HP and 50 mm in front of VP. In front and below, that means it will become under the fourth quadrant. Fourth quadrant, both the point will be below the XY line. So 70 and 50, that it will be the reverse of second quadrant. So very simple to remember. So here again we can select the line here 70, enter, again enter you can give, and here again same line you can take 50. So point will give, another one entered, you can give the point. So meanwhile we'll give the dimension also, because dimension is most important thing, and here also you can give the dimension for this. Yeah, both should be in the same line, and here also similar thing, reverse of second one, and this is also, yeah. And now naming we need to give, this is the D point. So D point will be there like here top view, so go for the text, or you can there copy from there also. This is the D point, and this is your D dash point. Now next question we'll see, draw the projection of point E lying on the HP. So lying on HP and 50 mm in front of VP. So 50 mm in front of VP, that means first quadrant, and lying on HP. So it will be there like one thing is given lying on HP and in front of VP. So top view will be down and front view will be on the HP itself, that means on the origin itself. So one point will be on the reference line, another point will be on below the XY line. So for this we can go, okay, let's go here. Directly we can select the point, and we can give one location here at this point, and the line we can select from this point how much distance, 50 mm distance is there. I hope 50 mm is there. Let's see the question again. Yeah, 50 mm. So another type point we can give, and the dimension again we need to give here, here to here 50 mm, and again we can go for the text itself. So lastly we will give the text, otherwise we will complete it first. The next question is given, draw the projection of a point F lying on 70 mm above HP and on the VP. So on the VP given, that means on the XY line it will be there, reference line, and above HP, that means the front will become vertical plane, and above XY line. So one location is there on this, again PO enter. So this is on this point, L enter, here how much, 70 is there, and dimension we can give here to here 70, PO enter, and we can select this point over. And next this is the DE point, E point, let F point completed. Next question is, we'll see G point. Draw the projection of point lying on HP, on the reference line, and 50 mm behind VP. So 50 mm behind VP, that means it will become under the second quadrant. So it will be rotated, and both will come above XY. One will be on the reference line, another one will be above XY line. So 50 mm is there. So we'll go to this, again PO enter, select this point, and line enter, L enter, 50. Completed. This is point location, and the distance you can give, height how much is there we can give. Okay, this is the dimension, actually dimension we need to select 50. G point completed. Next H point. The projection of point H lying 70 mm above HP above HP, it may be first or second quadrant, and on the VP. Above HP, on the VP. This is similar kind of question we have seen, I think. Point HP line 17 mm above the HP on the VP. Okay. So actually this should be okay. Sorry, it is given on the HP. VP should be reversed actually. Okay. Anyway, we will see. Let complete this last question. Draw the projection of a point J lying on both HP and VP. That means both the point will be the point will be on the reference line itself. Okay, and here we need to give the location J point, JJ dash. So here the text will be given single and text, and 3 enter 0. One we can give J, another one is we can give J dash. And let's see, we'll complete the text part. Text part for EE dash. This is E point, and this is your E dash, and this is your next is F dash. This is your F point, and this is your F dash point. F completed. Next G dash. This is your G point, and this is your G dash point. Now let's see the question of H. What is given? Draw the projection of a point H lying on 70 mm above HP on the VP. On the VP and above HP. No. This is the question, not same question. It should be actually different. So the question actually somehow different will be there actually for this. We'll see the question number 8. Let's see what is this question given. The projection of a point H lying on HP, lying 70 mm above HP. Above HP, that means it should become up. Okay, which already we have completed actually. So this question given wrong. Anyway, that question can be modified. That question can be modified into this will be below HP actually. This is not above. This is below HP and on the VP. So below HP it will be come down, and on the VP it will on the horizontal plane itself. So both will become one point will become below the HP and another point will be on the reference line. So the H can be drawn here. Yeah, line from this point we can select, and it is how much? 70 is there. Sorry, below is there now, that we need to take down. So how much? 70. Enter. So point, and this is one point, another point is this. So now we have to give the dimension for this. Select this point, give the dimension, and go for the text, single line text, H point. Take text direction 3, H0, and this is H, and this is your H dash, I hope. So let's see, H dash, and meanwhile other points we can mark it. So this is all about the projection of points. So I hope all of you understood about this projection of points. If any kind of doubts and problems are there, you can give me a comment in my comment box. So I will try to solve the doubt of yours. And this is all about actually projection of points. Similar manner we can go for the projection of lines and planes, all the things. Yeah, thank you all of you.